My life consists of two passions. On one hand, there is of course 3D animation, but on the other hand, I'm actually a data scientist because in 2023 I graduated my bachelor's in applied mathematics and currently I'm doing my master's in data science in business and entrepreneurship. So I got very excited when I found out that we can now import real datasets into Blender 4.5 using the new Import CSV Node. So in this video we're going to combine Blender with data science to visualize the population of the Earth like this. So the dataset that we're going to use for this tutorial is this dataset from OpenDataSoft.com. This dataset contains information of every city around the world that has a population of more than 1,000 people. So we got information of like the country that it's in, or of course the population or the time zone. And most importantly, we have the longitude and latitude coordinations over here. However, you don't have to download this dataset yet because I made some modifications to it so that you can easily use it in Blender, and let me show you how I did that. So I downloaded this dataset and then I went into Jupyter Notebook to write some Python code to modify the dataset. So first of all, I import the dataset, of course, and then the first thing that I do is, of course, we have all these columns over here, right? But for our purpose in Blender, we don't really need all these columns. The only things that could be handy for us are the geoname ID, the name of the city, the population, and the location coordinates of the cities. So over here with the log function, I'm pulling those columns out of it so that we can continue with those. So that results in this dataset. For this dataset, the only thing that we need to do is change the coordinates column over here, because now it's like in this format, like the longitude and latitude are in one column, and this is now like a string. It's not like two numbers or something like that. So in this set of code, I'm first splitting these values so that we get two strings for either the longitude or the latitude, and those I convert into new columns like longitude and latitude, as you can see over here. However, those are then just strings and not numbers that we can use in Blender. So over here we set the type as float, of course. And then the last thing that I did is export this dataset as a CSV file, and that CSV file, we will use that in Blender, and that you can find in the link in the description. Download that and then you can jump into Blender and we can get started visualizing these cities. So when you're into Blender, you can go into the Geometry Nodes tab, and then if you click on the cube, we can create a new Geometry Nodes for it, and we can name this cities or something like that. And we don't need the actual cube, of course, so we're going to remove the group input as always. So what we want to do instead is we want to import that CSV file that I created earlier. So if we do Shift A, we can do an Import CSV Node. Connect that like so, and with this path, we're of course going to direct to the dataset. So if you click over here, you can go into the folder where you have saved the dataset and then open it like this. Then you see nothing is really happening. Actually, there is something happening because as you see over here, we have almost 150,000 points, and those points are all over here, very small, like this. I'm struggling a little bit, but yeah, like that. So first of all, what we're going to do is we're going to make the points a little bit bigger so that we can see them. So let's do a set point radius node right over here so that we can actually see the points. Let's make it like 0.2 or something like that. Looks like that we just have one point over here, but actually those 150,000 points are all stacked in that middle point over there, and that's not really what we want. We want to change the position of each point according to the longitude and latitude location of it. So if you go over here into the points, then you see that we have the columns over here for latitude, longitude, and population inside of Blender, and that's amazing. Because what we can do now is, for example, a set position node to actually be able to change the position of the points. And now if we do a named attribute node, we can actually import that latitude and longitude information inside of Blender. And then we could say, of course, that the longitude should become the x-axis of the points and the latitude should become the y-axis of the points. However, at the moment, the XYZ over here is stacked into one thing, so we cannot really do anything with it. But if we do a combine XYZ node and connect it like this, we can connect the longitude with the X and the latitude with the Y. And then you see you're already getting the actual Earth and the continents and the countries mapped in 2D in Blender. And I think that's already quite cool, of course. However, we do not really want that these things are in 2D. No, we want to have this in 3D. We actually want to have like a globe of points. And to do that, we actually need to do some mathematics. So after searching a little bit on the internet, I came to these formulas to use as the XYZ coordinates of the points. So let us create that right now. For the x-axis, you see that we need to have the cosine of the longitude. So let's do a math node and let's set this on cosine, and now we have the cosine of the longitude, as you can see. But we also need to multiply this by the cosine of the latitude. So let's take this node, shift D it over here, and now we want to multiply this. So let me actually disconnect these two, and let's do Control Shift right click these nodes. You can do that if you have the Node Wrangler add-on enabled, and then change this to a multiply node. That's good, but you also see that we need to multiply this by some constant, and this constant is later going to determine how big the globe should be. So let's already implement that with another multiply node, and let's put that over here, and let's also do a value node, and let's connect that like this. Let's set the value node on 4 for now or something like that, doesn't really matter, but this is going to be our x-axis, so let's connect that like so. Then you see we basically have to do the same thing for the y-axis, except we take the sine of the longitude instead of the cosine of the longitude. So if we take these nodes, shift D them over here, and we just connect the longitude and the latitude like this, we can change this cosine to sine, and then also remove this value node, of course, and connect this one to keep things procedural. And then this is going to be our y-axis. Then the final thing is the z-axis, and the z-axis is just the sine of the latitude. So if we take this sine node, shift D it to over here, connect the latitude like this, and then we need to multiply this with the c value again. So let's do that in this way, very easy. This is going to be the z-axis, so let's put that like this. And you see, nice, we do have a globe, and if we make it bigger, that works too. However, you see, yeah, we're not really seeing any continents, right? Or any countries or any land whatsoever. And the reason for that is because this longitude and latitude information is currently in degrees and not in radians. And these formulas that we're using over here actually only work with radians and not with degrees. So we need to convert those degrees into radians. So we can do that by adding in a math node, and we're going to set this on 2 radians. And then if you do shift right click to make a joint over here, you can set the 2 radians like this. And then let's do the same thing over here. And let's take this node and do shift D to duplicate it over there. And then you see we actually get the Earth in a perfect way. And I think this is already quite a cool result, to be honest. However, as you remembered, we also have a column that is called population. So for each point that we see over here, so for each city, we know how many people are living there. And we can make the size of the point dependent on the population. So the bigger the population, the bigger the point will be. And that we can do by using this set point radius node. So if we do a named attribute again, and this time we're going to make this the population. Now, if we put the population straight up into the radius, then you see, that's not really good. The reason the points are like looking so glitchy right now is because this population value goes from like 1,000 to like millions to like really high. And that's not really going to look good. So we kind of want to remap this so that it doesn't go from 1,000 to 1,000,000, but it goes from a very small number to another very small number, so to say. So if we do a map range node and set that over here, at the moment this map range node thinks that the population goes from 0 to 1. However, it doesn't. It goes from like 1,000 to like in the millions or something like that. But since we do not know an exact number for this min and max over here, we cannot really manually fill it in. So what we want to do instead is we want to extract the exact min and max population from this geometry. So if we do an attribute statistic, we can connect that like so and then connect the population with it. Now we have the exact min and max population of the entire dataset connected like so and then like so. And then you see, okay, some of them disappeared because like the to min value is 0 and that's a bit too small. So let's make that a bit higher, like 0.02 or something like that. Then you see it's all a bit more visual. So let me put the max value on 0.7, for example. Then you see it works because look over here, for example. We have a lot of small villages or cities over here, but then there's this big, huge city, which of course is London. And of course over here, let's see. Yeah, over here we have Turkey with Istanbul, for example. And over here in Spain, we have Madrid, of course. And for my American audience, we of course over here have New York too. So yeah, that's already looking pretty cool. And what I think is also really cool to see is, for example, over here with Italy and France and Switzerland, you really see that over here there are less villages, and also over here too. Well, with this, you not only see where are villages, but you can also see like where are mountains, for example, because over here in the Alps, there are just less villages than over here, for example. And the data scientist in me find that quite cool to see, to be honest. And a cool thing with working with just raw points in Blender is that if we go into cycles over here and turn on our GPU, if we then go into render view mode, you see, if I put the light a bit more over here, you see that the points transform in these spheres, which means that we do not have to manually instance icospheres on these points with a lot of geometry, so to say, because these spheres that you see over here are not adding any vertices to our scene. So using the raw points like we are doing over here is a very efficient technique. However, I do want to talk about some things when you're working with the Import CSV node, some things that you have to look out for. So the Import CSV node, it's a very new node, and at the moment it can only work with numerical columns. So it's not capable of importing any columns that have strings, for example, the name of the city or the time zone of the city. It's not capable of doing that yet. I hope they're going to add that feature in the future though. And another practical thing that you need to watch out for is this delimiter over here. Because if you're working with a dataset or a CSV file from which the values need to be separated with something else than a comma, for example, like an what's the name again? For example, a semicolon, then you will have to set the delimiter, of course, to semicolon. But in our case, that doesn't work because our CSV file is separated by a comma, as you can see over here. Okay, so now that we have all the points in a perfect way around the globe, I think we should actually create the Earth like I had in my introduction video, right? Because just the floating points, that's a little bit boring. However, before we do that, I want to talk to you about something else, because I can completely understand if you're looking at these nodes that you're thinking, oh my god, what is all of this? I have no idea what I'm looking at. How am I ever going to learn all these nodes? I wish there was just some place in which I can just learn every single node in geometry nodes in a very easy and chill way. But then I have good news for you, because I released the big notebook. It's a book that explains every single node in geometry nodes in a very easy and chill way. The book starts from the very basics of geometry nodes, and over the course of 200 pages it goes to more advanced techniques. The book is available on my Gumroad and it has been fully upgraded to Blender 4.5, so every new node has been added in. And also, if you use the code DATA, you will get 25% off of your purchase. So if you want to expand your knowledge in geometry nodes, I recommend getting this book today. And with that being said, let's continue the tutorial. So for the actual Earth, we're going to press Shift A and we're going to go into Mesh and then UV Sphere. And then you can press S to make that a lot bigger. Just make it so that the points are kind of covering it. And let's also do Ctrl 1 to add in a subdivision surface modifier with a level of 1 to it. For now, I think it would be good if we hide our points with H so that they are not in the way when we are creating our Earth. For our Earth, we want to go into material preview mode and let's go into the shader editor to create a new material, and let's call this Earth. And the first thing that I want to do is to create the outline of where it is land and where it is water, of course. And that we're going to do with this image. So you can find that image in the link in the description, download that, and then we can import that with an image texture node and click on open. And then we can open it up like so. And then if you connect it with the base color, then you see that works perfectly fine. And very quickly, it even works with the points, as you can see. For this, you would think, okay, but with this image, how are we going to create that outline, so to say? We're going to use the actual blur that you see over here. You see when it goes from black to white, you see that there's kind of a blur, and that we can use to create the outline. So if you do a math node, which we set on greater than, and then if we do a very small number like 0.1 for example, and then if we do the same thing but reversed, so if we do Shift D over here and we connect it like this and we set this on less than, and we set this on 0.3 for example, then you will see, okay, you're getting the reverse, and there is kind of an overlap between the two, which is pretty good, because if we now do a math node and we multiply these two together like so, then you see you're getting an outline around the countries, and it works perfectly. So this is going to be the mask for the emission over here, because I want these lines to glow. So if we connect this with the strength of the emission and we connect the principal BSDF again, then you see if we put the strength up with a math node set to multiply and we set this on 10, then we make the strength 10 times higher. Later, when we go into render view mode, you will really be able to see that this is glowing. But let's set this for now on like a blue color or something like that. Something like this, yes. And actually, let's also do right click and shade smooth for our thing so that it looks smooth. And also I figured it would be cool if we make our globe a little bit metallic. So if we put the metallic all the way to 1 and then the roughness a bit higher, later when we're going to create our space scene, that's going to look very cool. The next thing that I want to do for our Earth is to create some atmosphere around the edges of the globe. And that we're going to do in a very easy way, because if we do a layer weight node and we preview this, then you see that it already looks like an atmosphere. And this we want to add to the strength of the emission. If we make a little bit more space and we add in a math node and we connect it like this, then you see, okay, that kind of already works. If we make the blend of the layer weight a little bit lower to like 0.02 or something like that, and we also make a math node to make the layer weight a little bit stronger, so let's multiply this by 10, then you see that looks really nice, I think. Of course, you can change these variables to your needs, of course, but for this, I actually think it looks quite cool. Okay, the next thing for our globe is to actually create the grid that goes over the oceans. So to do this, we're going to use a little bit of geometry nodes. So let's go over here, split our screen like so, and let's change this to the geometry node editor. And then if we create a new geometry node, so we can name this grid. And to create the grid, we first need to convert the edges of the sphere into curves. So if we do a mesh to curve node right over there, then you see, okay, nice, we have a grid. However, we do not really have the actual thing anymore. Like the actual Earth is gone. So if we do Ctrl Shift right click these nodes, then we join the grid with the original Earth, and that works like this then. However, you see that the grid is also going on the land right now, and that's not what we want. I think it looks cool if the grid only goes on the water. So what we want to do is delete the points if they are on land. And for that, we are again going to use this image, of course. If we do a delete geometry nodes, and this selection socket needs to be driven by that image that I just showed you. So if we do an image texture node in geometry nodes, we can click open and then do that image again and put the color into the selection. Then you see, okay, that kinda already starts working, right? But you see, it looks a bit weird. It's not really looking as if the grid is following the water and the land at all. And the reason for that is the way this image texture is now mapped onto the grid. And I'm not really sure in what way it is mapped right now, but it's definitely not using the UV map of the original sphere yet. But that's actually what we want. We want to use the UV map of the sphere to map the texture on the grid. And that we can do with a named attribute node set to UV map, and then connect that with the vector. And then you see, okay, that looks a lot better. However, you see it's reversed. It's now on the land and not on the water. So if we do a map range node, and then we can say, okay, don't make it go from 0 to 1, but make it go from 1 to 0. And then you see it's on the water, and that's perfect. You also see it's also stopping a bit too early. It's like those chunks of emptiness over here. And the reason why it's always deleting a full edge and not just part of an edge is because each edge over here consists of 2 points, like a point over here and a point over here, but no points in between, so to say. And that's exactly what we want to have. And to be honest, that's quite easy to do because these are all curves. And if we want to have multiple points on a curve, we can just do a resample curve node and set this on like 50 or something like that. And then you see it's already becoming more accurate. But you do see that there are still some parts not really working. And that's because this deletes geometry nodes. For some reason, it has some difficulties with deleting points from a curve. But if we convert the curve into a mesh before the delete geometry, for some reason it then works. So if we do a curve to mesh node right in front of it, then you see it's already way more accurate. And we can set the count even higher to like 100 or something like that. And then you see that works everywhere. Okay, maybe 100 is going to be a little bit too much. So let's set this on 60 or something like that. Now we have a really nice grid that is following only the water. However, the curves don't really have thickness yet. And that we can also do over here with the curve to mesh. Because if we set a profile curve to be a curve circle, we can connect it like so. Then you see, okay, it's like boom again. Let's first of all set the resolution of the curves a little bit lower to like 6 so that our performance is a little bit better. And let's set the radius of the curve circle lower to like 0.05. And then let's set the scaling of the curve to mesh lower to like 0.02 so that we have a really nice grid like this. Maybe let's make it a little bit lower, like 0.005 or something like that. And then I think that looks quite cool. Now the final thing for the grid is going to be a material. So let's do a set material node over there. And let's create a new material by going into the shader editor. And let's click on plus over here to create a new material. And let's call this grid. And for the grid, we only need an emission node, of course, because we only want it to emit light. And let's make the grid over here grid. And let's set the strength on like 6 or something like that. And let's set the color a little bit more blue. Let's see it in render view mode. If we set over here in the world properties, the color lower to black. Let's see. Okay, my computer is not really liking it that much. Okay, yes, there it is. By the way, if you go into render view mode and you see over here that updating lights, which takes quite some time. If you go over here into render properties and under lights, if you turn off light tree, then if you do that again, then it doesn't have to do that updating lights again, and it goes way faster with the exact same results. I'm not really sure why that is a thing, but if you turn light tree off, then you're good to go. So let's bring back our points. And then you see, okay, the points are still there, but they are not really visible. So what I want to do is I want to make these points glow too. So to make the points glow, we're going to make a new material for it. And I see that I already have a material for this. So let's make this cities or something like that. And let's remove the principal BSTF and let's make this an emission again. And let's also go over here into the geometry nodes and let's do a set material node set to cities. And let's set the strength of the points on like 20 for now. But I also want to make the color of the points dependent on the population of that certain city. And of course, we could do this by adding in an attribute node over here and name this population. However, if we connect it like so, then you see the points are becoming way too bright. And that's because the numbers of this population go way too high. So what I also want to do is to remap this population in the shader editor, just like we did in the geometry nodes. However, in the shader editor, we don't really have an attribute statistic node so that we get the exact min and max value of the population. So what I want to do instead is I want to remap it in geometry nodes and then export it into the shader editor. And that we can do with a store named attribute node. And let's name this pop scaled. And let's make a bit more space. And let's also add in a map range node so that we can map the population from its original min max value from 0 to 1. And then if we connect that like so, now we can say over here, pop scaled, and then you see, okay, the colors go over here now from black to white. So if you now want it to not go from black to white, but from blue to red, for example, you can do a color ramp node, and then you can change the black to a blue-ish, something like this, and the white to red. However, you don't really see that much red. Well, that's because only the cities with really the highest value get saturated red. So if we put the red value a little bit more over here, then you see more cities are covered as red cities, which looks a little bit better in my opinion. So from here, I also think we should reduce the radius of our points by making this to min value 0.002. I think that looks a lot better. A final thing I want to do for the material of these points is to also give the points a little bit of a glow, or like an atmosphere, so to say. And that we're going to do in a very easy way. So let's do a layer weight node again, and also a math node set to multiply. If you now connect it like so and like so, then you see we're already getting a glow. And then if you set the value on like 40 or something like that, then I think the points just look a little bit more interesting. And then also I don't think it looks really good if the points are floating so much above our Earth. So first of all, we can of course make the C value a little bit lower so that the points are more on the Earth. But as you can see, it's not really that perfect. So I really want to snap the points to the nearest surface of the Earth. And that we're going to do over here with a set position node. And let me actually go into solid view mode for now. If I zoom in on these points, for example, now to make the position of the points the nearest surface of this sphere, we can actually drag in the sphere into our geometry nodes, set this on relative, and then we can do a geometry proximity node, connect it like so, and then this is the position of the nearest face of each point. So if we connect it like so, then you see the points are perfectly snapped on the face, and that looks then like this. But then you also see that there is a slight offset in where the points are located compared to the actual Earth that we created, and the easiest way to fix this is just do it the manual way. So if we do R twice, so R, then we can move the points a little bit up like so, kind of like this, kind of like this, and then I think that looks quite cool. You know what, let me also show you how I did that space atmosphere that you saw in the introduction video, and that actually consists of two parts. So on one hand we have the colorful volumetrics that go around the Earth, and then we also have a lot of stars that are surrounding it. But for the atmosphere, we first want to do Shift A and add in a cube and make that cube a lot bigger. And let's go into material preview mode for now. And of course we don't really need to see the cube, so let's go into the object properties for the cube. Let's go into viewport display and do display as wire. So now for this cube you can go into the shader editor and create a new material called volume. Actually for this I'm not going to do it one by one, I'm actually going to give you the material. So for the volume material you're going to need this node setup. However, if you then recreated those nodes and go into cycles, then you don't really see anything. Well, if you want to see the smoke, you're going to need a light and sunlight. So if you then put the strength of the light a little bit higher, then you start seeing these volumetrics. We might want to make it go a little bit lower. So maybe like so or something like that. So the volumetrics is basically created with two noise textures. This noise texture is controlling the density of our object, and this noise texture is controlling the hue of a hue saturation value node so that we can change the color of the volume to make it look more like an sci-fi space scene or something like that. And then for the stars, that's also quite an easy process. So if you go Shift A and you do a mesh and then an icosphere and you make that a lot bigger, something like this, and you right click shade smooth, of course. Now, if you take this icosphere and also go into viewport display and display as wire, then you see the icosphere is white from the top and black from the bottom. The reason for that is because the sunlight is also affecting that mesh. However, I want that the sunlight is only affecting the smoke. If we click on the cube for the smoke and we press M to create a new collection, we can name this fog or something like that. And then if you click on the sun, then you can go into the object properties, and under shading, we can do light linking. So if we do over here fog, then you see it's only affecting the fog and nothing else. So now if we go back into the icosphere, the way I did those stars is with this simple node setup. So what we have over here is of course a Voronoi texture that looks like this. And then with a less than node, we can create those little stars over here. And this output drives the alpha and the emission strength of the principal BSDF so that it actually emits a little bit of light, and that looks like this. And I think that looks quite cool, to be honest. And then one final thing that I want to do for this tutorial is to show you how I did the compositing for the scenes so that you can go from this result to this final result. So for that, let's first set up the camera. So if we go into camera view and then click over here on this lock camera view and then do Control B and drag like this so that we only see the camera, and then we can zoom out a lot and make it go on any part of the earth, but I will do it on my home, of course. But then you see, okay, we look through the camera, but the stars and the space is gone. Well, that's because the camera cannot look that far. So if we click on the camera and go over here into the object data properties, we can change the clip ending to like 500 or something like that. And then you will see you're actually seeing it. Let's also change a little bit of render settings. So if we go into the render properties, let's set the max samples for now on 128. That's completely fine for this scene. And then we can go into render and do render image. Okay, then this is our final result. Of course, it already looks quite cool, but we can make it so much cooler. So let's go back into Blender and let's go into the compositing tab and let's click on use nodes. Let's go into view and make it zoom out a little bit like so. So the compositing setup that I used is this setup. You can recreate that and then we'll go over it again. Nice. This is the node setup. Let me go over it one by one. So first of all, we add in a glare node so that we can get some glow around the brighter parts, as you can see. I did change the variables a bit so that the size is not too big or the strength is not too big. So like this, for example, but I liked it more like so. So this before and after. And then the biggest change that I always do to make things look a bit more cinematic is by creating a mask like this. Oh, and also if you think that it's taking a little bit too long to load with the compositor, that's because by default the compositor is driven by your CPU, but you can also set it to make it use your GPU. So if you press N to make this sidebar open up, you can go into options and then under device change it to GPU, and then you will see that it already goes a lot faster, like almost instantly. So I created this mask over here which has darker corners so that you can get more focus in the middle. And if you multiply this mask with the original image, then you're getting that the corners are way darker and you're getting more focus on the thing that you want to focus on, like the middle point. And then I also did some lens distortion because I think that looks quite cool. So this is before and this is after. Now it really looks like it has that distortion that a real camera lens would have. Actually, now that I think of it, what we could do to make this look even cooler is to do our little bit of color balance. So if you do that like this, if we make the lift value a little bit more bluish, that kind of looks cool, I think. Yes, that makes it look even more sci-fi, to be honest. And of course, if you go into layout again and go into camera view and render view mode and then turn off the overlays, you can also get the compositing results in real time by going into compositor and turn on camera. And then you see it looks like this. That's pretty cool. And with that, I think we have looked at quite quite a cool example of using the Import CSV Node in Blender. And that already brings us to the end of this tutorial. I hope you liked this video again, and if you did, please give this video a thumbs up, comment down below if you have any questions, and if you don't want to miss out on any future videos, I recommend subscribing to the channel. And also check out the big notebook by going into the link in the description to get 25% off of your purchase. And with that being said, I see you in the next one.